we have seen that is BT complete. It should be whenever you take it as a heap, a binary tree should be, that is, I'll just write it as a BT, is a complete binary tree. It should be a complete binary tree with all its levels are full except the last level. This is first important thing, rule. And what is the next rule? The parental dominance, that is, and this is also important, except the last level, that is rightmost, where only the rightmost leaves may be missing. This is very important. And the second rule is parental dominance. That is, parent, when you consider a parent node is greater than or equal to the keys or child. Okay, this is very important. Now we will see some examples for this. I'll write some examples. Okay, the first thing, look here, I'll just write some example. 10, 5, 4, 2, 7, 1. This is a complete binary tree. Look here, there are all different nodes over here. This level is full. This is a second level. This is a first level. This is full. That is, it is having a root. And when you come to the second level, look, two different parents are there. This is also full. The last level, look here, this is the last level. As I told you, it is a complete binary tree. You know what is a binary tree? It can either be just root, or it can be 2 levels, or it can be 3 levels. This is a binary tree. And this is a complete binary tree where it is having all the levels are full except the last level. Look here, this last level is not full. Even if it is not full, it is a heap, because they are telling the whenever you take a tree, all levels must be full except the last level, where, look here, you should always, and whenever you are moving from a last level, you should always move from left to right. This is very, very important in trees. We should always move in this direction. Okay, when you move in this direction, look here, this left node is there, left is full, right is full, and look here, this left is full, and here somewhere the right is missing, right? Here the root is not there, sorry, the leaf is not there. This is what, look here, they have given a condition, only rightmost leaves may be missing. Even you don't have a right node, that is also considered as a heap tree. Understood? This is very, very important. This is a complete binary tree. Here somewhere right is missing. Even the right leaf is not there. This is the right leaf missing. Even this is not there. It is considered as a binary tree, and it is a heap tree. This is very, very important. Okay, this is one condition we have to see. For example, this is the first condition I am telling you. Next, when you come to the second condition, look here. This is a parent of this node, right? For example, now I will take this. 7 is a parent of this child 1. This is a child. So always see to that the parent is always larger than the child. This is very important. Look here, 7. 7 is greater than 1, right? If, for example, I'll consider somewhere my parent, for example, I'll consider like this. I'll consider 10. Somewhere I'll consider this as 5, and this is 7, and this is 2. For example, I'll consider this as a tree. Okay, this as a tree where rightmost is missing for me. It is okay. This is a small tree. Can you tell me this is a heap now? First condition is satisfied. Even it is not having a rightmost child, or for example, sorry, this you should consider level. You should complete the level. For example, I'll write this as 4, and somewhere I'll write this as 1. Okay. Now this is satisfying with the first condition. This is a complete binary tree. Well, this level is full, this level is full. Somewhere at the last level, rightmost is missing. Okay. Now, this is very important. We have to even see the second condition. Now, see to that second condition, the parent should always be larger than the children. Now, when you come this, for example, you see 10. 10 is greater than 5 and 4. Yes, the condition is true for here. But when you come to the next level, 5 and 4, now you have to check with this children. Is 5 is greater than 7? No. At that time, what we have to do? We have to swap the parent and the child. When this condition is not satisfying, swap the parent and child, construct a new tree. This is what heapifying we tell. If it is not a complete binary tree and it is not satisfying any two conditions, we have to make it we have to change the tree in such a way that it should satisfy the condition. Now look here, the parent, whichever it is smaller than the child. So you have to swap it in such a way that you should go there and you have to bring the child to the lesser. Now look here, 10. I'll write this as, I will swap, I will make it as 7, then I will come to 5, then here 2, then here 4, here 1. Now this is a heap. Okay, these are the conditions we need to see. First condition, all the levels are full, and if even the rightmost trees are missing, it is okay. The second condition is always parent should be greater than the child. Understood? This is if the parent is not greater than the child, swap it. And whenever you are seeing that, for example, now 5 is there, I am comparing with 7 and 2. For example, here if 9 is there, what you have to do is you have to see which one is larger and you have to swap that with the parent. Okay. Now 2 was small, so I did not do. If 9 is there, compare 7 and 9, which one is larger, then swap the parent with that number. Okay. 7 is lesser than 9, so I am swapping that with 9. Okay, you have to compare the two children also with the parent. Which one is larger, swap that with the parent. That's all. That is based on the tree whichever we have. Understood? This is how we have to construct a heap. Understood? This is how important rule we have to consider for heaps. Artha aita? These are the two important rules that should be satisfied for a tree. When you have a tree, it should be a complete binary tree with any of the rightmost children can be missing, but all the levels should be filled, and very important thing is parent should also be always greater or equal to the child. This is very, very important. You understood this? Chidru?
Yes, ma'am.
Understood? That is what the first important thing we have to note down for the heaps. Okay. Now we will go with the next one. List of important properties of heaps. Can you see this? Are you able to see the screen?
Yes, ma'am.
Okay. So what are the important properties of heaps? Look here. The height of the complete binary tree with n node is called is log n. These are certain important properties you have to note down, because this is very, very important question. They'll ask you this for 5 marks. List the important properties of heaps. This is very, very important question. Okay. The height of a complete binary tree, you know the height is nothing but the number of levels which are there, that is -1. That is known as a height. You know that, right? Height, level and all, you people know this from the data structures. This is very important. The height of a complete binary tree with n nodes is equal to log n. This is very, very important. These are the properties of heaps. The height of a heap is always will be log n. Okay. The root of a heap always contains its largest element. This is very, very important. When you have a tree, the root will be always largest among all the parents present in the tree. This is very important for heap. Okay. A node of a heap considered with all its descendants is also called as a heap. Whatever the descendants, you keep on writing. Any number of children you write, any number of leaves you write, any number of parents you write. Last, whatever you consider, even the smallest children or the smallest leaves, they are also considered as a heap. Heap is nothing but everything, whatever you keep on adding, every node, whatever you keep on adding, that is considered as a heap in the tree. Okay. Heap can be implemented as an array by recording its elements in the top down, left to right fashion. Okay. For example, this is a tree, whichever you have. This is considered as a heap for me. And you can represent this as an array like this. Look here, the array representation, that is top down, left to right. From top you have to come, and from left to right you have to move. I'll write that and I'll show you. Okay, that is one property. Okay, understood that? The height of heap is always log n. The root of heap is always, it's the largest element. The node of a heap is considered, even if it is a descendant, whatever the descendants, whatever you keep on adding, everything is considered as an heap. Heap can be implemented as an array by recording its elements in top down, left to right fashion. I'll show you what is that. Okay, then look here, these are the very important, two important things for greedy method. Look here, the parental node keys will be in the first n by 2 positions of an array, while the leaf key will occupy the last n by 2. You people know the greedy method, right? First n by 2, whichever you know, that n by 2. I'll write and I'll show this. The first n by 2 is the parent, and next whatever you keep on dividing, those are children. You people already know this, right? The left and right children of a node I will be a positions 2i and 2i plus 1 respectively. The parent of a key in the position I will be in position I plus 2. This is just a thing. When I write n by 2, you will come to know that. Now I'll just write that n by 2 and I'll show you what is that. It is easy once I write it. Okay, now you are able to see the screen.
Yes, ma'am.
Now I take this as a heap. For example, this is a heap for me. Now how I do represent to an array, as they are telling you need to represent this in a form of an array. You can represent in a form of an array that is moving from top to right. That is top to bottom. From top to bottom you have to move from here like this. From top to bottom. Top to bottom you have to move, and whenever you are moving from top to bottom, you reach the levels, you should write from left to right. For example, now I'll take this as a root node. I'll represent an array like this. For example, I'll represent an array. I'll first write the root node. Next, come to the level. This is the first level. How you have to move to the levels? You have to move from left to right. Now, which number I have to write? I have to write 7. Then I have to write 4. Understood? This is how we need to represent trees in form of array. Then after completing this level, move to this level. In this level, move from left to right. So write 5, 2, 1. This is how you need to represent a heap in an array. This is array representation. Understood how to write this? Artha aita? Now you people have to tell me. Now, for example, this is there. This example is there. Tell me how to represent it in form of an array. Tell me how to represent this in form of an array. Now, what I should write? I want answers from you people. Akriti. Akriti. If you don't respond to my questions, I'll mark absent for you people. Akriti Gupta. Adarsh. Illa. Just why you people just keep your phones, and I don't know what you people are, whether you people are listening or not. I even don't know that. Arun. Arun. Am I audible to you people?
Yes, ma'am.
Ah. Arun? No. Ayanpal? Ayan?
Yes, ma'am.
Yeah. Tell me how I represent this in the form of an array. Now I'm taking this an array. I'm taking this as a heap. Now I should represent in form of an array. Now tell me how should I represent that? If they consider this as a heap, what should I do now? Which number I should write first? Answer, I
Ma'am, it should be in ascending order.
I told it as an ascending order now. Then what are you listening? Bhavana? Bhavana? Bhavya? If you are silent in my class, from next class, I'll not do any of the algorithms. I'll not solve anything. You know, DAI is very, very difficult. When you don't understand any of the techniques, whichever we are seeing, just reading from the notes is very difficult. Bhavana? Bhavya? Gagan?
Yes, ma'am.
Okay. ಇದು ಹೆಂಗಪ್ಪ represent ಮಾಡ್ತೀಯಾ? How do you represent this in array? Tell me. I'll write that. ಪಾಠ ಕೇಳಿಸ್ಕೊಳ್ತಾ ಇದ್ದೀರಾ ಇಲ್ವಾ? ಗಗನ್?
ಕೇಳಿಸ್ಕೊಂತಿದ್ದೀನಿ ಮ್ಯಾಮ್.
ಮತ್ತೆ ಹೇಳು ಇದಕ್ಕೆ ಆನ್ಸರ್ ಹೇಳು. If this is a heap, how do I represent this in a form of an array? Ganvi?
ಮ್ಯಾಮ್ ಫಸ್ಟ್ 10 ಬರೀತೀವಿ ಮ್ಯಾಮ್.
Okay. Next.
7 ಮ್ಯಾಮ್.
7 ನಾ? Ganvi? Okay, ಹೇಳು. ನೀನ್ 7 ಹೇಳ್ತಾ ಇದ್ಯಾ. 7. Next. Gagan?
Ma'am, 10,
ma'am.
5, 4, 2, 7, 1, ma'am.
Who is that? Who is that now told the answer? Okay, ಹೇಳು. ಗಗನ್ ಹೇಳು. ನೆಕ್ಸ್ಟ್ 7 ಆದ್ಮೇಲೆ?
ಮ್ಯಾಮ್ ನಂಗೆ ಕರೆಕ್ಟ್ ಆಗಿ ಗೊತ್ತಿಲ್ಲ ಮ್ಯಾಮ್.
ಮತ್ತೆ ಏನ್ ಮಾಡ್ತಿದ್ದೆ ಇವಾಗ ನಾನು ಪಾಠ ಮಾಡ್ತಿದ್ರೆ? ನಾವ್ ಇಷ್ಟೊಂದು ಕಷ್ಟಪಟ್ಟು ಡೈಲಿ ಈ ತರ ಏನೋ ಒಂದು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿ ಬೋರ್ಡ್ ತಗೊಂಡು ಅದ್ರಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿ ನಿಮ್ಗೆ ಕಷ್ಟ ಆಗತ್ತೆ.
ಇದೊಂದೇ ಮಿಸ್ ಮಾಡ್ತೇನೆ ಮ್ಯಾಮ್. ಫಸ್ಟ್ ರೂಲ್ಸ್ ಅರ್ಥ ಆಯ್ತು ಮ್ಯಾಮ್.
ಏನ್ ಮಾಡ್ತಿದ್ದೆ ನಾನು ಹೇಳ್ತಿದ್ದಾಗ? ಪಾಠ ಕೇಳಿಸ್ಕೊಳ್ರು. ಎಕ್ಸಾಮ್ ಕಷ್ಟ ಆಗತ್ತೆ ಇವೆಲ್ಲ ಬರೆಯೋದಕ್ಕೆ. Okay, look here, whenever you are writing, those who have not understood, those who have not listened properly, now look this carefully. When the particular heap is given, you have to represent this in a form of an array. What we have to do, you start from the root, write the root as a first element and come to the next level. When you come to the levels, always move from left to right. So whatever the parental node in the left side, write that here first. Okay, 5 I will write. Next I will come to 7. That level is completed. Now come to the next level, move from left to right, write all the elements from left to right which are there in the next level. 4, 2, 1. Okay, this is how we represent in a form of an array. Understood?
Yes, ma'am.
This is how we represent. For example,
Yes,
you can
ma'am.
keep indexing 0, 1, 2, 3, 4, 5 is an indexing. And for example, look here, these are the leaves. 4, 2, 1, these are the leaves. These are all parents. This is the first level, this is the second level, this is the third level. This is how you have to represent when a heap is given. You have to represent this in a form of an array. Understood? This is the array representation. Now when you have a greedy technique, for example, this is an array. I told you when a greedy technique is there, always we take n, we divide this by n by 2, then n by 2, again we divide this by n by 4, n by 4, again we divide this by n by 4, n by 4. This is what we do, right? This is what they have given in the rule, that is parental node key will be in the first n by 2 positions. This is first n by 2. This is the parent, this is the parent. If I consider this as a leaf, these will be the children for me. Next n by 2 or next n by 4, they will be the children's for me. This is what they are telling in the rule, that's all. Okay, these are parents. These are parents and these are the children. This is what the rule they are telling, that's all. This is how we divide when we take a tree. This is what, this is n, this is n by 2, this is n by 2, this is n by 4, this is n by 4, n by 4. So when you have this tree, this n by 2, n by 2, n by 2 representations will be as a parent, and the remaining representations what we take, they will be as a children. This is what the rule, that's all. Okay, understood? In this, when you have a heap, very important, these two important rules are important, very important two rules. Apart from the two rules, you have to show an example. You have to write a binary tree and show the two important rules. That is first rule. It should be a complete binary tree. Even the left, right children are missing. Even though it is missing, it is a complete binary tree for a heap. And then the parent should always be greater than the children. These are the two important things. And when a heap is given, how to represent a heap in a form of an array, this is how you represent. That is, take a root in the beginning and always go to the next level, write from left to right. Move from left to right, keep on writing them. 7, 4 and last level, from left to right, keep on moving like this. This is how we represent an array. Okay, this is what the rules they have given. Those are very important thing you people have to note down and you people have to remember for the heaps. Okay, now I will go with the next important thing, next important topic of the heaps. Very important. Look here, this one. So when you have a heap, two important alternatives or two important techniques to represent a heap. That is, for example, certain number. For example, look here, I'll give 10, 5, 7, 4, 2, 1. I will ask you to write a heap or I will ask you to construct a binary tree. You people know complete binary tree. You people know even binary tree construction. That is, the parent will be there, left hand side will be greater, right hand side will be smaller. You did this in your data structures. That construction is very easy. But how to construct a heap when a normal numbers are given? That is how to construct a heap. There are two ways: bottom up heap construction and top down heap construction. These are the two important algorithms to construct a heap. Okay, so very important thing is two important algorithms are there. Bottom up, that is from bottom to up we will go, that is one construction. Top to bottom we will come, that is a second construction. These are the two ways to construct a heap, to construct a tree. If you have a numbers. Okay, so first we will go with bottom up construction, then we will go with the top down construction. These two are important, very important. They'll ask you the question. For example, look here, they'll give you a number like this and they'll ask you to construct the heap whether in bottom down approach or top down approach. This is very important thing you people have to note down. Okay, now first we will consider bottom up heap construction. What is this bottom up heap construction? When you have a bottom up heap construction, look here, these are the important rules to note down for constructing a tree. What are those two? It initializes the essentially complete binary tree with n nodes by placing keys in order given and then heapify the tree. This is the two important things we have to do. That is, we have to place the keys in order. That is, level wise we have to place the numbers. And after placing the number, we have to heapify the tree. What is that heapifying? What is that placing? We have to know that with these rules. Look here, starting with the last parental node and ending with the root, the algorithm checks whether the parental dominance holds correct. This is very important. Look here, this parental dominance. Whenever you are placing a key in the node, whenever you are placing a key in the tree, see to that the parent node is greater than the children node. That is very important to construct a heap. Parental dominance is the first thing. Now, if it doesn't match the parental dominance, what we have to do? We have to swap them. That is, algorithm exchange the node key with a larger key of its children and check whether the parental dominance holds for the key in the new position. Okay, you have to keep insert a nodes and construct a tree. After constructing a tree, see to that parent is greater than the child. If it is not greater, swap it and do that. That swapping, whatever we are do, that is known as heapification. That is known as heapification. Look here, after the heapification of the subtree rooted at a current position node, the algorithm proceeds and do it for everything. Okay, now look here. What is this heapification? Taking a parent, checking that with the child, comparing. If it is parent is lesser, swap it. Doing swapping of that, that is known as heapification. That's all. I'll write and I'll show you what is that. Then you people can easily understand. This is what bottom up heap construction. Always we will see the numbers. Look here, I will see a number. I will construct each number. I take it as a key or node. I'll construct a tree. After constructing a tree, check whether the parent is larger than the child. That is, from bottom we have to go to the top. This is bottom up approach. From down level we have to move to the upper level. That is, first thing, see whether from left to right we have to move. This is always very important. Whatever the tree is considered, anything, always move from left to right. Okay, whatever the action you are doing, I'm moving from left to right, that action is heapification. I'm changing the parent and the child, that is heapification. Whatever the action you do, that is known as heapification in our sorting technique. Okay, now I'll take this and I'll explain this. This is very, very important. We will go with that. These two are the rules we have to consider. Okay, now are you able to see the screen?
Yes, ma'am.
Now we will go with the first important approach, that is, we will see with okay, two approaches. First one is bottom up approach and top down approach. First we will go with bottom up. What is this bottom up approach? A number of list of elements will be given. Okay, from that construct a tree. Okay, this is first, this is second step, then third step. After constructing a tree, see parental dominance. From bottom to top. This is very important. From bottom to top and from left to right. This is very, very important. These are the important, three important things you have to see and repeat this. Repeat third step until root is largest of all. Understood? This is what the things we have to do. This is not explained in our notes. These are the simple techniques you need to follow to construct a bottom-up approach. Okay, now we will go with a simple example. For example, there was a simple numbers given. Okay, so I will take the number. For example, look, 2, 9, 7, 6, 5, 8. So the list of numbers will be given like this. What you have to do? You have to, the list of elements will be given. First step is okay. Now construct a tree from this. How to construct a tree? Look here. Very, very important. Move from this. Take a number. Keep on adding that. That's all. Look here. This is very, very important. Very important. Construct a tree now. Just keep on writing a numbers. 2 from left to right. First element should be considered it as a root. Now consider it as a root. Now remaining elements keep on moving from left to right. That's all. Okay. Now what is the remaining next element? 9. What is the next element? 7. First level is completed. Now take the next element 6. Next element 5. Next element 8. Like this you have to write, that's all. Okay. First element should be considered as a root. Next elements keep on moving from left to right. Okay. Now I have constructed a tree. This is what the second step. Construct a tree. That's all. This is the heap tree, right? This is the heap, but the parental dominance is not there. That is, this is the binary tree where only right hand is missing. It is okay. It is a binary tree. Now after this construction, now move to the third step. Now from bottom to top you have to go. That is, from bottom to top. See the parental dominance from bottom to the top. This is very important. Understood? From bottom to top we have to go. Don't come from top to bottom, from bottom to top. Okay, that is what. And always see to that whenever you are seeing a parental dominance, always see to that after writing this, first complete this, then go to this tree. Complete this tree, then move to this tree. Okay, that is very important. Now look here. 2, 9, 6, 5, 7 and 8. Okay, now I will go with this tree first. See to this tree where parent is greater than child. See this parental dominance. Is parental dominance okay with this? Is parental dominance correct in this? Correct, Idya? No, because 7 is lesser than 8. So now what we have to do? Swap this. That is what heapification or parental dominance. Now I should bring the largest number to the parent. Okay, now after
Ma'am, ನಿಮ್ಮ ವಾಯ್ಸ್ ಬ್ರೇಕ್ ಆಗ್ತಿದೆ ಮ್ಯಾಮ್.
network issues ಇರಬೇಕಪ್ಪ. ಈಗ
ಓಕೆ ಮ್ಯಾಮ್.
okay. Now see, parent is larger than child. Parent is not larger, swap it. That is known as heapification. Now after swapping what? You'll get a new tree. 9, this is 6, this is 5. After swapping what I'll get? 8 and 7. Okay, this is what now this first right side of the tree is completed. This is completed. Now again come to the left hand side. Now you have to see the left hand side. In this left hand side, look here. In this left hand side, the parental dominance is correct for me. In this, now come to the left hand side. Move to the left hand side. Is the parental dominance okay with me? Parental dominance correct agidya? Now see this. Iveredu check ಮಾಡಿ. Parental is okay? Yes. Everything is okay. No need to swap anything. Okay, now come take it as a one tree now. I will take it as a tree. Now I have completed with all the bottom level I have completed. Bottom level completed. Once you complete this level, then only you have to go with this level. Okay. So now 9, 8, 6, 5, 7. This bottom level is completed. See now, all these are lesser than these are the parents. All these are lesser. Okay, now I should again see with this level now. Come to this level. This level is okay. Now come to this level. Check this level. Okay, this level is completed. First, I have to check with this parental level. This level is completed for me. Now, see here. Now, where I have to see? I have to see here. Now, this level I have to see. Okay, now, look here. Now, see the parental level with this levels. Because only one parent is there for this. Only one root is there for these two. Now, is the root greater than the children?
No, ma'am.
No, ma'am.
What we have to do? We have to swap. So now where to swap? Either I should swap 2 with 9 or 2 with 8.
2 with
9,
8.
ma'am.
9, because the larger number we have to take, swap this. So now I got this. 9, 2, 6, 5, 8. Okay. Now after this level, I came here. These are all okay with me. Then I came to this level. I need swap, and again I got this tree. Now again in this tree, what is there? Can you tell me, is this tree correct? After completing this, I came to root and I got a root. Root is the largest number I got. Root is largest of all. Yes, 9 I am largest and root I got. But now again I have to consider this tree, whether it is properly according to heap or not. Tell me whether this is correct according to heap.
No, ma'am, not correct.
No, ma'am.
Why? Parental dominance is not there, right? Again, that is what I have to do this. Look here, repeat the step 3 until root is largest and parental dominance is correct. Okay, until the parental dominance is there, keep on repeating the same steps again and again. Now what happens? Now I have to go with this. Look here, this parent is smaller than the children. So what I have to do? I have to compare these two now. I have to see which one is largest and bring among to the top. Now I have to do heapification. That is what? Do the parental dominance. That is known as heapification. Now I have to swap. Where you will swap this? With whom I will
2
swap?
to 6, ma'am.
Yes. So now I will write this as 9, 6, 2, 5, 8. Now this is a new tree I got. Now is this tree complete according to the heap? Tell me all parental dominance is okay. Look here. Root is larger than 6 and 8. Yes, it is true. Now come to this level. 6 and 8 are parents. For example, I should take 7 here. Sorry, I forgot. Now, these two are parents. See, 6 is larger than 2 and 5. Yes.